If proof of work sounds something new for you, then you've come to the right place. Proof of work is the first and the most popular consensus model in cryptocurrency networks. First introduced in '93, the concept was developed to protect the network from denial of service attacks, or simply DOS. DOS attacks make the network inaccessible for intended users by flooding the target with traffic and triggering a crash. So how does proof of work in crypto networks work? Let me explain everything in a step-by-step guide. Hey guys, Shad here with another lesson on our cryptocurrency course for beginners. I guarantee that by the end of it, you'll have all the necessary skills and knowledge to make money with cryptocurrency yourself. So let's roll. In 2009, Bitcoin introduced proof of work as the consensus algorithm within the network, and since then, it is considered to be the first consensus algorithm of all networks. On the blockchain, the proof of work confirms transactions and produces new blocks to the chain. So, how does this all actually work? Well, in a network, a user sends each other digital tokens. A decentralized ledger collects all transactions into the blocks. However, the ledger needs extra help to arrange and confirm all transactions in the blocks. The responsibility to check and confirm transactions lies with special nodes within the system. These nodes are called miners, and the process of arranging and confirming transactions is called mining. Miners compete with each other in solving complex computational puzzles. And what do I mean by complex computational puzzles? And there are actually a lot of puzzles which need to be cracked. For example, hash functions, or how to find an input knowing an output, or even integer factorization, or how to present a number as a multiplication of two other numbers, or even the guided Tor puzzle protocol, or how to find a chain of hash functions. There's so many. The answer to the proof of work problem is called a hash. As the network is growing, it needs more and more hash power to solve computational puzzles. Accurate work and the speed of the blockchain depends on the complexity of said task. In other words, it's all about balance. If block generation takes a lot of time and needs a lot of computational power, then a transaction will be stuck, and as a result, the workflow hangs for some time and you have a slow chain. On the other hand, if the solution is too simple, it will be prone to DOS attacks and spam. The solution needs to be easily checked so nodes can analyze if the calculations are correct. If a miner finds a solution to the puzzle, they can broadcast a block to the network. Other miners should then confirm and verify the solution to the block. Let's take a look at how proof of work works within Bitcoin. So as I told you, miners are competing with one against each other, solving computational puzzles and forming new blocks and confirming new transactions. And the complexity of puzzles depends on many factors like the number of users, the current power, and network load. Miners are responsible for adding new blocks into the blockchain. To do that, a miner must guess a pseudo number, also known as a nonce. In combination with the block data and once passed through the hash, this number must provide a result which matches with given conditions. If the matching result is found, then other nodes will check the validity of the computations. And if everything is in order, then the miner will be receiving a reward. Miners earn rewards in coins for every block solved, and as you would have guessed it, these coins can be Bitcoin, Ethereum, Litecoin, and other cryptocurrencies, depending on the mining of the blockchain itself. So in the proof of work algorithm, it's impossible to add a new block to the main chain without finding a valid nonce. This nonce will provide a solution to a specific block that is also called the block hash. And each block's hash contains the hash of the previous block, which increases security and prevents any block violation. In other words, each block contains a block hash that proves the work completed by the previous miner. That's why it's called proof of work. So where is proof of work implemented? Of course, the most famous application of proof of work is in Bitcoin. It was the founding father, so to speak, of this consensus. The puzzle they use is Hashcash. This algorithm allows for changing the complexity of the puzzle based on the total power of the network. The average time for block formation is usually around 10 minutes. Litecoin and ETH are other blockchains that have similar algorithms. Moreover, most of the projects based on the Ethereum platform also use this POW, proof of work model. So what are the advantages of using proof of work? The first and main one is protection against DOS attacks. Proof of work imposes some limits on actions in the network. Therefore, any DOS attack needs a lot of computing power to be executed, which means many calculations need to be undertaken. In other words, DOS is possible but not reasonable. It's expensive, it's difficult. The second one is a low impact of stake on mining. In other words, it doesn't matter how much money you have in your pocket because it doesn't affect the computational power. What you really need is the computational power to be the first one to provide the solutions to the puzzles. But what about the disadvantages of proof of work? And of course, it does come with some. The main disadvantages are huge expenditures, uselessness of computations, and 51% attacks. Let's start with the problem of huge expenditure. Mining requires highly specialized computer hardware to solve puzzles. It requires investments in both hardware and power. And yes, mining consumes a lot of power. Bitcoin uses as much energy as the whole of Switzerland every single year. As for the uselessness of computations, well, miners use a lot of power to solve puzzles. However, the calculations they undertake are useless anyway anywhere outside of the network. It can't be applied to any business, science, or social project. Moreover, only the winning node gets a reward. That means the calculations performed by all the loser nodes are useless even within the network. And the third disadvantage is the 51% attack possibility when one or a group of users control 51% of the mining power within a network. That's how they can monopolize generating new blocks. Currently, 51% attacks are not a profitable option as it requires a lot of money computational power to be executed. And if other users do notice the attack, they will immediately dump the tokens on the market, which will inevitably move the price down. Alright, we've covered a lot for today. Let's summarize what we have for now. First, proof of work is the first and the most popular consensus model in cryptocurrency networks. It's definitely one to know about. In the proof of work model, a decentralized ledger collects all transactions into blocks, and these blocks are generated and confirmed by special nodes called miners. The miners receive rewards for completing blocks, and each block contains the block hash that proves the work done by the previous miner, the proof of the work. That's why it's called proof of work. Proof of work's main advantages include anti-DOS attacks, great defense, and low impact of stake on mining possibilities. The disadvantages, however, are the huge expenditures needed to mine, the uselessness of computations, and the vulnerability somewhere down the road for 51% attacks. Of course, proof of work is not the only popular model of consensus. There is also an algorithm called proof of stake, but we will learn more about that next time. So I'll see you in the next lesson of our crypto course for beginners. My name was Shad, this was EXMO Cryptocurrency Exchange, and I hope you learned something new.